Introduction to Organic Chemistry Part 1. Learning Objectives. At the end of the module, you must be able to 1. Discuss the overview of general chemistry. 2. Identify the structure of an atom. 3. Explain how electrons of an atom are distributed. 4. Determine the relevance of ionic and covalent bonds. 5. Recognize the concept of acids and bases. 6. Distinguish the nomenclature and structure of alkanes, alkenes, alkynes, carboxylic acids, aldehydes and ketones. Introduction to Organic Chemistry. To stay alive, early humans must have been able to distinguish between the different kinds of materials in their world. By the early 18th century, scientists thought they had grasped the nature of that difference. 1807, Jöns Jacob Berzelius gave names to two kinds of materials: living organisms that contain immeasurable vital force, essence of life; compounds derived from minerals, lacking the vital force. 1828, Friedrich Wöhler produced urea compound known to be excreted by heating ammonium cyanate, an inorganic material, O plus heat, NH4OCN, C, H2NNH2, urea, an organic compound. For the first time, an organic compound had been obtained from something other than a living organism and, certainly without the aid of any kind of vital force. Chemists therefore needed a new definition for organic compounds. Organic compounds. Compounds that contain carbon. It is the study of carbon compounds. Every living organism is made of organic chemicals, the proteins that make up your hair, skin, and muscles, the DNA that controls your genetic information, the food that nourish you, and the medicines that heal you are all organic chemicals. Anyone with a curiosity about life and living things, and anyone who wants to be a part of the remarkable advances now occurring in medicines and the biological sciences, must first understand organic chemistry. Consists of tiny, dense nucleus surrounded by electrons that are spread throughout relatively large volume of space around the nucleus called an electron cloud. The nucleus contains protons, positively charged particles, and neutrons, uncharged particles, so it is positively charged. Electrons, negatively charged. The amount of positive charge on proton equals the amount of negative charge on an electron. Therefore, the number of proton equals the amount of negative charge on an electron. Protons and neutrons have approximately the same mass and are about 1800 times more massive than an electron. Mass of an atom in the nucleus. Volume of an atom in the electrons. Atomic number of protons in its nucleus. Unique to a particular element. Number of protons in an atom of a particular element never changes. Mass number sum of its protons and neutrons. Atomic weight average mass of its atoms. Molecular weight sum of the atomic weights of all the atoms in a molecule. How the electrons in an atom are distributed. The electron in an atom can be thought of as occupying a set of concentric shells that surround the nucleus. The first shell is the one closest to the nucleus. The second shell lies farther from the nucleus. The third and higher numbered shells lie even farther out. Subshells where electrons reside in particular energy levels. Each shell is further divided into sublevels of increasing energy, named S, P, D, and F. Electronic configuration describes what orbitals the electrons occupy. 3 rules specify which orbitals an atom's electrons occupy. 1. An electron always goes into the available orbital with the lowest energy. 2. No more than 2 electrons can occupy each atomic orbital, and the 2 electrons must be of opposite spin. 3. When there are 2 or more atomic orbitals with the same energy, an electron will occupy an empty orbital before it will pair up with another electron. Electron repulsion is minimized. Core electrons in inner shells. Valence electrons in outer shells. Elements in the same column in the periodic table have the same number of valence electrons because it is the major factor determining an element's chemical properties. Thank you. See you at next video. Please subscribe.